So now let us move on to exercise number 1.3. Okay. So here the first question is, write the following in decimal form and say what kind of decimal expansion each has. So we have learned there are three types of decimal expansion: terminating, non-terminating, repeating, and non-terminating, non-repeating. So they are asking you to write the following fractions in decimal form and say what type of decimal expansion are they. Okay, so the first question here is 36 by 100. So we all know 36 by 100, anything divided by 100 or 10 or 0, we can just move the 0 over here. So we will get 0.36. Okay, so if you see 0.36, the after the decimal point the numbers are coming to a stop. After that a remainder becomes 0. So then definitely if it is stopping after a particular number after the decimal point, it surely will be terminating decimal expansion. Okay, I hope I am clear. Now the second question is 1 by 11. So here I have done the division for you. When we do 1 by 11, you just observe over here. We had start with 1 and again we are getting the same thing. Okay, and again we get the remainder 1 if we are doing it again also. So here it is 1, I will put a 0 over here. Once again I have to put a 0. We know 11, so here also 0. 11 times 9, we know it is 99. Again when we do the subtraction, we are getting the same number 1. What does that mean? It means that after the decimal point, the number 09 is repeating and going. So how can we write 0.090909 can be written as 0.09 bar. So if after the decimal point a particular number is repeating and going on like that, we can call it as non-terminating recurring or non-terminating repeating decimal expansion. I hope I am clear. Now the next question is it is a question which is given in your mixed fraction. So before we find the expansion or find the decimal expansion of it, we have to make it into a proper fraction. So I hope you remember the way in which we make it into proper fractions. We have to do 4 into 8 plus 1 divided by the denominator. This into this plus 1. That is the way in which we make mixed fractions into proper fractions. So when we do 4 into 8, we will get 32. 32 plus 1, we will get 38. And always don't forget to divide it by the denominator. This is the way in which we make mixed fraction into proper fraction. So I got here 33 by 8. Okay, so here also when we do 33 by 8, we are observing that we are getting a remainder to be equal to 0. So if our remainder becomes 0, what does it imply? After the decimal point, after a particular number, our expansion is stopped or it terminates. So definitely there is nothing repeating and going on, or there is no random numbers which are going on. It is stopping at a particular place. So definitely it will be a terminating decimal expansion. So our next question is 3 by 30. So here also, when we do a decimal expansion of 3 by 30, you have to just see over here. After we had started with 3 by 30, then after so many times we are getting back again this 3. So we had started at 3, and when we do our division and go, we are getting back a 3. What does that mean? After this much places, the numbers again starts to repeat. That means if you see the quotient over here, we got it as 0.230769. That means after this 9, again this entire process will start again. So after this 9, again 230769, 230769 repeats and goes. So what does that mean? It means that this term, that is 230769, is repeating and going in a particular manner. So definitely it will be non-terminating recurring or non-terminating repeating decimal expansion. Okay, I hope I am clear. The next one is 2 by 11. Just similarly, when we do the long division and go, finally after 4 places after when we do the long division, we are getting this 2 back again. That means after these many decimal places, the numbers again starts to repeat. Okay, here we got 90 by 88. Here also we are getting 90 by 88. That means that the same number will be repeating and going. So when we do, we will get 0.18 bar, which means 18, 18, 18, 18 is repeating and going. So definitely this also will be non-terminating recurring. Okay, I hope I am clear. Now the last one is 329 by 400. So here when we do a long division, we see that we get a denominator as we get a remainder as 0. So when we get a remainder as 0, what does that mean? After the decimal point, our number comes to an end. It stops, it terminates. So definitely this will be a terminating decimal expansion. Okay, now let us move on to our question number 2. The question says, you know that 1 by 7 is equal to 0.142857 bar. Can you predict with what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without actually doing the long division? Okay, this is a very interesting question. Okay, so they have already given you the value of 1 by 7 by doing the long division as 0.142857. Now they are asking you to find the value of these numbers without doing the long division. So how will you do this? So here always in such questions, whatever is given to you in the question, we have to use that given quantity to find our answer. So in our question, 1 by 7 to 1 by 7. So you know 2 into 1 is what itself? 2 by 7 itself. So I am just splitting it and writing it as 2 into 1 by 7. Now we know that in the question the value of 1 by 7 is given to you as 0.142857. So we have to just multiply this 2 with this 1 by 7's value given to you. So now don't worry about this bar and all. Just do as you do your normal multiplication. So I have 0.142857 into 2 over here. Okay, so when I do 2 sevens are we know 14, 2 fives are 10, 11, 2 six are 16, 17, 4, 5, 8, 2. Okay, just like you do your normal multiplication, just do it. So we will be getting the answer as 0.28514 bar. Okay, this is the value of 2 by 7, and without doing a long division we got a value, because in a question the value of 1 by 7 was given. So we just did a manipulation and wrote this as 2 into 1 by 7. Then simply multiply this 2 into the value of 1 by 7 which is given to you in your question. So you will be getting your answer. Similarly, you can proceed with the other things that they have asked you. So if they ask you 3 by 7, just do 3. Take 3 out. 3 into 1 by 7. So 3 into this. So you will be getting 0.42871. Similarly, 4 by 7, just do 4 into 1 by 7. You will be getting 0.571428. Similarly, 5 by 7, do 5 into 1 by 7. You will get 0.714285 bar. Similarly, here also do 6 into 1 by 7. You will be getting 0.857142 bar. Okay. Now let us move on to our third question. The question says, express the following in the form of P by Q, where P and Q are integers and Q not equal to 0. Okay, this is a similar type of question we had in our example. Okay, so here the first question is express 0.6 bar in the form of P by Q. So let's see. This is the thing we have to express in the form of P by Q. So I hope you remember the steps that we had done in our example question. Whatever they are asking you to find in the form of P by Q, take it as X. So we can any unknown variable, no need for x, we can take y, z, anything we can take. So I wrote x is equal to 0.6 bar. Now what was our next step? We have to check under how many numbers this bar is present. So this bar is present under only one digit. If it is present under only one digit, we have to multiply the LHS and RHS with 10. If it was present under two numbers, we have to multiply both sides with 100. So since it is present only at one number, we have to multiply LHS and RHS with 10. Okay, so I will get 10x is equal to, 0.6 into 10 means 1 decimal points move over here. I will get 6. So I will write that 6 point I have to put. Then whatever thing is repeating, or the thing or the number above which the bar is present, just copy down it as it is over here. Okay, so now if you observe, we have got our two equations. This we can take it as a equation number 1. This we can take it as an equation number 2. Now what we have to do? Big minus small. So we have to do second equation minus first equation. So I will get 10x is equal to 6.6 bar minus of, I will write x is equal to 0.6 bar. We know 10 minus 1 is 9x is equal to, here you will get 0 and here you will be getting 6. Okay, 6 minus 6 is 0. Now here we have got a linear equation over here and we know how to solve it. We got 9x is equal to 6. So when this 9 goes to the other side, it will go to the denominator. So I will get x is equal to 6 by 9. So now I can cancel both the things with 3. So if I cancel it with 3, I will get the answer as x is equal to 2 by 3. Okay, this is my answer. X is equal to 2 by 3. How did I get? Now if you want to know whether your answer is correct, just divide and see 2 by 3 and check whether you are getting the answer as 0.6. This is the way in which you can check whether your answer is correct or not. Okay, so our next question is 0.47 bar. Okay, here also our first step is just consider the number whose fraction we have to find as x. So we will write x is equal to 0.7 bar. Now what is the next step? You have to check how many numbers are there between this bar symbol. Okay, here the bar symbol is present under only one number, that is 10. So we have to multiply LHS and RHS with 10. Now after the decimal point there are two digits, but don't look these two, 4 and 7. We have to look only the number under which the bar is present. The bar is present under above only the 7. So we have to multiply both the sides with 10. Okay, so I will write 10x is equal to 0.47 into 10. So when we do this, what will we get? 0470. We have to move 2 decimal places. We will be getting the answer as 4.7. Okay, we will get, when we do 0.747 into 10, we will get our answer as 4.7. Okay, I wrote 4.7. Now what is the next step? Whatever thing is repeating, just copy it down as it is after the decimal point. Okay, so I got 4.77 bar under 17. Okay, this I can take it as equation number 1. This I can take it as equation number 2. Now what should we do? Big minus small. That is second equation minus first equation. So the second equation is 10x is equal to 4.7 bar and the first equation is x is equal to 0.47 bar. Okay, just subtract it. So when you subtract 7 minus 7, 0. 7 minus 4 is 3 and here we will get 4. Now then 10 minus 1, it is 9x over here. Okay, so we will get 9x is equal to 4.3. So just like you solve your linear equation, we can do 9x is equal to 4.30 or 4.3. Okay, then x is equal to, this goes to the denominator, so I will get 4.3 divided by 9. And we know whenever they ask you to write it in the form of p by q, we cannot have decimal in the decimals, so just multiply both the numerator and denominator with 10 to remove the decimal. So here we will get 43 divided by 90. Okay, I hope I am clear. This is your p by q form, and if you want to check whether it is correct or not, you can just divide these two numbers and see whether you are getting the answer as 0.47 bar. Okay. So our next question is 0.001 bar. Okay, so let us do first step. We have to consider this thing as x, so I will write x is equal to 0.001 bar. Now the next step is we have to check under this bar how many numbers are there. So here we see there are 3 numbers under this bar. So if there are 3 numbers, if there is only one number, multiply by 10. If there is 2 numbers, multiply by 100. And if there is 3 numbers, we have to multiply both sides with 1000. Okay, so I will get 1000 x is equal to, just see how I am multiplying, 0.001 into, when I do 1000 I will get 0001, here 3 zeros, and we have to move 3 decimal places towards the right. So I will be getting here 1 point. Now after you write like this, what should you do? Whatever thing is repeating after the under which the bar is present, just copy it down after the decimal point as it is. Okay, so you will be getting 1.001. Okay, I hope I am clear. Okay, see, always after the decimal point there might be some number or there might be no number. Whatever it is after the decimal point, whatever number is repeating, or whatever the number above which the bar symbol is present, copy it down as it is, because it will be helpful for you for doing the calculation. Okay, so take this as equation 1, take this as equation 2. Now big minus small we should do. So second equation minus first equation. So 1000 x is equal to 1.001 bar. We have to subtract it from x is equal to 0.001 bar. So here just observe, this entire thing cancels off and we will get over here 1 only. 1000 minus 1 is 999, x is equal to 1. Okay, we got a linear equation over here, that is 999, x is equal to 1. So from here what will we get? X is equal to 1 by 999. Okay, this is your answer. Okay, I hope I am clear. X is equal to 1 by 999. So in order to check if the answer is correct, just divide 1 with 999 and see whether you are getting 0.001 bar. Okay, let's move on to question number 4. The question says express 0.9999 in the form of p by q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. Okay, so this is just like the question that we did previously in question number 3. Okay, they are basically asking you to express 0.99 in the form of p by q. That means we have to make it into a fraction form. So here if you see, this 9 is repeating and going, so I can definitely write 0.99 etc. as 0.9 bar. Okay, this is the thing whose fraction we have to find. So like in the previous questions, we should take this 0.9 bar as x, so we can write x is equal to 0.9 bar. Okay, the bar symbol is present under only one number, so multiply both sides with 10. So I will get 10x is equal to 0.9 into 10. When I do, I will get 9 over here. Okay, because one decimal place is moved from there. Then after that, what should you do? Put the decimal point and we have to copy down the number which is repeating, or the number above which the bar is present, which is 9. Okay, that is our next step. Okay, so we got two equations over here. We can take this as equation number 1. We can take this as equation number 2. Next, what do you have to do? Big minus small. That is second equation minus first equation. So I will write 10x is equal to 9.9 bar. Okay, we are subtracting it from x is equal to 0.9 bar. Okay, so when we do the subtraction, here we will get 0. Here we will get 9. 10 minus 1 is 9x, and here Okay, so when we do the subtraction, here we will get 0, here we will get 9, 10 minus 1 is 9x, and here we got a linear equation, 9x is equal to 9, so from here we will get x is equal to 9 by 9, which cancels off, and finally we will get x is equal to 1. Okay, this is the answer that we are getting. Now, in our question they are asking you, are you surprised by this answer? Yes, definitely yes. Why? Because here we got x is equal to 1, x is equal to 1 by 1. If you are dividing 1 with 1 itself, we will get our answer as 1 only. Then how can this be how can 1 be the decimal expansion of 0.999? This is the surprise that we are getting. So from here we can make we can conclude a statement that the value of, so here we will get 1 is approximately equal to 0.999. Okay, this is the symbol we use for approximately. Okay, so basically that is the surprise that they are talking. That is x is equal to 1 is a rational number, and even if we do 1 divided by 1 we will get 1 only. Then how can it be equal to 0.9? So basically we are assuming that this 1 should be approximately equal to 0.999. Okay, that is the thing that you should know over here. Definitely this answer makes sense. Okay, now let us move on to our next question. Okay, so now let us move on to our question number 5. The question says, what can the maximum number of digits be in the repeating blocks of digits in the decimal expansion of 1 by 7? Perform the long division to check your answer. Okay, so if you see, you can see this is a very lengthy long division that you have done. So when you do this long division and go up till here, after so many rows, we see that this 1 repeats after here. Okay, after so many places we see from where we have started, we have come again over there. So again if you do the long division here, again we will get 185, and it goes on like this. So up till here the decimal expansion we are getting of 1 by 17 is 0.0588235294117647. It is going on like this, and they are asking you for what can be the maximum number of digits be in the repeating block. So just see that just see that below this bar how many numbers are there. If you count and see, we will see that there are 16 digits over there. Okay, if you count and see, there are 16 digits, after which again we are getting this 1 back, or after which again this 05823 is repeating and going. Okay, so you can definitely do this division and see after how many decimal places the numbers are repeating again. So over here. Okay, now let us move on to our next question. Okay, so our next question is 6th question. Look at several examples of rational numbers in the form p by q, where p and q are integers with no common factors other than 1 and having terminating decimal representation. Can you guess what property q must satisfy? Okay, so this is a very interesting question. Okay, so let us take a few examples of our fractions that are having terminating decimal expansion and see what property the denominator. Okay, q means the denominator they are telling you it should have. Okay, so just see, I have written 2 by 5 over here. Okay, so when I do 2 by 5, I am getting the answer as 0.4, which is terminating. Similarly, if I do 11 by 4 also, I am getting 2.75. Okay, now you just observe the denominators of all the examples that we have taken. It is either 5, or it is the denominator is either 5 or 2, or the powers of these two. So if you see over here, here 2 by 5, the denominator is 5. So we got a terminating decimal expansion. Here we have got 11 by 4. Now we know 11 by 4. 4 can be written as 2 square. So it is definitely a it is a 2 or it is a power of 2. So definitely one thing that we can note is that if the denominator given to you is 2, okay, if the denominator is 2 or 5 or 2 raised to something or 5 raised to something, it is definitely a terminating decimal expansion. Okay, also if it is 2 raised to something into 5 raised to something, then also it will have a terminating decimal expansion. So if you see the example of 9 by 100, I can write it as 2 square into 5 square. So 2 square we know it is 4 and 5 square we know it is 25. So 4 into 20. So if we can write the denominator as 2 raised to something or 5 raised to something, or there is simply 2 and 5 in the denominator, or we can write it as 2 raised to something multiplied by 5 raised to something. If the denominator is basically of this form, definitely it will have a terminating decimal expansion. So here they are asking you what should be the property that q, that is the denominator, must satisfy for a fraction to have a terminating decimal expansion. So you can write, if the denominator is 2 or 5 or 2 raised to the power something or 5 raised to the power something, or if the denominator is of the form 2 raised to something into 5 raised to something, definitely it will be a terminating decimal expansion. Okay, I hope I am clear. Okay, so let us move to our question number 7. The question says, write 3 numbers whose decimal expansion are non-terminating, non-recurring. So this is one of the most simplest question in your exercise. So whenever we write, they are asking you to write just an example of it. So we can write any number of examples. Okay, it's just non-terminating, non-recurring. Here are a few examples which I have written. Non-terminating, non-recurring means that after the decimal point, there is the numbers repeat in no particular order. It goes to random. So you can always make your own example and write also. But one thing that you should remember is you should never forget to put this dot 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 and clear with it. Okay, that was our question number 7. Okay, so now let us move on to our 8th question. The question says, find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay, this is like a similar question that we had done in our example question. So, in order to find irrational number between 2 rational number, first of all find the expanded form or the decimal expansion of 5 by 7. So, if you see over here, we got 0.71 and 0.81. So just see 0.71. So the number has to be between 71 and 81. So here if we see these two numbers, the number should be greater than 2. So we know after 1 it is 2. So we should start writing a number with 0.72. So I can write 0.726542 and it goes on like that. You can write any random number because it is non-terminating, non-recurring. Similarly, I wrote 0.720 etc. I can also write 0.73 or 74576 etc. 2, 3, 1, 2, 0 and it goes on like this. So you can write any number which lies between 0.71 and 0.81. Okay, that is the thing that they are asking you. So just ignore these 4 to 8 and all. Just find any number which is lying between 0.71 and 0.81 and just write any 3 non-terminating, non-recurring numbers between these two. So you can write any example which you wish. That is the any number between 5 by 7 and 9 by 11. Okay, so let us move to our last question in our exercise, question number 9. The question is, classify the following numbers as rational or irrational. So we know how to differentiate between rational and irrational. Let us see one by one. So the first question is root 23. Okay, so is it rational or irrational? Definitely root 23 is irrational. Why is root 23 an irrational number? Because we know root 23 is an imperfect square root and we know all the imperfect square roots are irrational number. So definitely root 23 is an irrational number. Now the next question is square root of 225. So I hope you know that 15 square, that is 15 into 15 is equal to 225. So square root of 225 is equal to 15. Okay, so we know 15 can be written as 15 by 1. So definitely this is a perfect square root, and I have told you if it is a perfect square root, it will be a rational number because it can be written in the form of p by q. So our second question, it is a rational number. Okay, by seeing the square root, don't just write it irrational, just see if it is a perfect or a imperfect square root. So it is rational. Now question number 3 is 0.3796. So here we can see that after the point there is no bar or not dot dot dot. That means it terminates after the decimal point. So if it has a terminating decimal expansion, then definitely it will be a rational number. Okay, if it has a terminating decimal expansion, it is a rational number. Now our next fourth question is 7.4784784. So here we see that after the decimal point, this 784 is repeating and going. So I can write this as 7.4784, and this 784 is repeating, so I can put a bar over it. So if this 784 is repeating and going, definitely it will be a non-terminating recurring decimal expansion, and we know that if it is a non-terminating recurring decimal expansion, definitely it will be a rational number. I hope I am clear, because 784 is recurring, it is repeating and going. Okay, similarly the fifth question is 1.10101 etc. So here we can see after the decimal point there is no random order, and there is also dot dot dot, and it is simply repeating and going without any particular order. If it is so, it will be non-terminating, non-recurring. So if it is non-terminating, non-recurring, definitely it will be an irrational number. Okay. Okay. So now we have completed our exercise 1.3. So this actually I am following the old NCRT. So I hope in the new NCRT also it is exercise 1.3 itself given to you. Okay, so we have completed all our 9 questions. Okay, so in our next class we will start with a new topic. Thank you. Please like, share and subscribe.